All right, good morning, good afternoon, geometry. I just want to go over this practice test with you guys. So this first one here, I have AE over AF. So here's AE, here's AF equals AC over something. So AC is this part right here. I need to make it match up. So clearly I'm going to have to do this entire length here, this AH. So the answer there is going to be AH for 1A. So 1A will be AH. I could also say HA. Doesn't really matter what order I put the letters in, as long as I have the correct letters. All right. So 1B, I have something over FH is going to equal AG over AF. So AG over AF. So we can see that it goes all the way down the side and then across with that FH there. So if I go with this AG, I only go 2 lines down. I need to go across as well. So it needs to go across at that GB or BG. So since one line goes across, I have to have another one that's going to go across there. So it'll be GB or BG here. It doesn't really matter what order I put those letters in again. So GB. All right, 1C. So with this one, let's see, what do we got? Dang it. Okay, so 1C, I have FG over EA. So FG over EA. And then something over CA. All right, again, I want to make this match up. I can see that that EA is across from that CA. This FG is across from this HB. So it should be HB is my answer here, or BH. And then I have 1D. So for 1D here, BH over something. Let me make that bigger. BH over something is going to equal BC over GE. So here's BC, here's GE. All right, well, to make this match up, I should probably do this GF. So it's BH, and I should go GF. I could also say FG, doesn't really matter. So GF will be our answer to 1D there. And that's the answer to number one, AH, GB, HB, GF. All right, number two. So number two here, I have these proportional triangles. I have this angle bisector, and these are going to be proportional, so I can just match them up. It doesn't really matter how I write this proportion. I could say, we're going to call this question mark, we'll call that x. So I could say x over 15 and 10 over 25. I could say the 15 over the 25 and the x over the 10. So, you know, this x and this 15 are both on that side together. So I'm going to put them both on the top together. So I have the 15 and the x, but you know, no matter what, I should be writing proportions here. I can't just set things equal. So the 15 is crossing that 25, it's on that same triangle. And this x is on the same triangle as this 10. From here, we can just cross multiply and solve. So I cross multiply here. 15 times 10 will give me 150. 25 times x is 25x. And then divide both sides by 25 there. And we're going to get that x is going to equal 6 here. And that's number two. So, you know, just got to match up the things that are on the same triangles there. So the x and the 10, the 15 and the 25. And since the x and the 15 are both on the same side there, they should both go on the top or the bottom together. It doesn't really matter. All right. Let's see, number three. So number three, I got these parallel lines. Again, I have this is my x. I can do, let's see, the 4 over the x, because those are across from each other. So I'll say 4 over x. So the 4 is across from that x, so we can see. And the 5 is not across from the 18. So I can't say 5 over 18. That would be wrong. What I could do, I see that this entire thing is 18. I see that this part is x, so I could say this is 18 minus x here and say 5 over 18 minus x. That would work. Or what I could also do, what I would probably do in this case, is I see that 18 is the entire side length, and I see that this entire side length is 4 plus 5, so 9. So I could say 9 over 18. And since that 9 was on the same side as the 4, the 9 would go in top. So I could say 9 over 18 because 9 is the entire side length, 18 is the entire side length. And from here, we can cross multiply and solve. So 4 times 18 is 72. 9 times x is 9x. And divide both sides by 9 to get that x is going to equal 8. All right, so that's number 3. Number 4 is going to be pretty similar. So number 4 here, yet again, I have this x. So that's x. Let's see. Some things I can do. I see this x and this 6. So that's something I can pair up. The x and the 6 are on the same side. So the x over 6. And let's see, the 6 is across from the 4. So I can put the 4 on bottom there with the 6. But the x is not across from the 12. Again, so the entire side length here is 12. Instead of using 12, I just need to do 12 minus 4 because I know this entire thing is 12 and this part of it is 4. So I just need to do 12 minus 4 to get that this is going to be 8. So the x is across from the 8, meaning I can put 8 on top of this 4. From here, we can just cross multiply and solve. So I cross multiply there. I get 4x equals 48. Divide both sides by 4. And we get x is going to equal 12. And that's how to do number 4 and those first 4, I guess. All right, next, got number 5. This one's going to be relatively similar. It's just this time instead of just x, I have like an expression for x. So it's pretty similar to number 2, where I have the 2x plus 5 and the 20 are on the same triangle, and then the 6 and the 8 are on the same triangle. So what I can do here, I could say 2x plus 5 over 20 is going to equal 6 over 8. This 2x plus 5 and the 6 are on the same side of that triangle, so they can both go in the top. And then the 20 and the 8 make up entire side length, so they would go in the bottom together. From here, I can cross multiply to solve. So I have that 8 times the 2x plus 5 equals, let's see, 6 times 20 is 120. Distribute out this 8, so that gives me 16x plus 40 equals 120. Subtract 40 from both sides. So 16x equals 80, and then divide by 16. And I get x is going to equal 5. And there we go. So on number 5, the answer is x equals 5. Number 6. Okay, so here, let's see, some things I could do. I see this 6 is across from the 9, so I'll do that. I have the 6 across from the 9. And then, let's see, I have this part right there is across from that 3 plus 3x. I can't call this x over here because it's not x. X is a separate variable over there. Again, I can do the 14 minus the 6 to get that this part here is going to be 8 because I know this entire length is 14. I know that this part of it is 6, so I can do 14 minus 6 to get that this is 8. Another thing I could have done, so let's see, I'll set that up. I have the 8 across from the 3 plus 3x. So 8 over 3 plus 3x. Another thing I could have done is, I see this entire length here is 14. And if I wanted this entire length, so I could have said 14 over, 3 plus 3x plus 9. I can combine the 3 and the 9 to make 12 plus 3x. So I could have also said, 14 over 12 plus 3x, because the 14 is across from the 12 plus 3x. But I'm not going to work with that one, but that is an option as well. So from here, we can cross multiply and solve. So I have the 6 times that 3 plus 3x is going to equal 8 times 9 is 72. Distribute out this 6. So I have 18 plus 18x equals 72. subtract 18 from both sides. I have 18x equals 54. Divide both sides by 18. And I get x equals 3. And that's our answer there. Okay. And on number 7, again, just pay attention to what the entire side length is, what's across from what. So I have this 20 across from this 15 I can work with. So I can do 20 over 15. And then I have, let's see, I could do, well, I don't know. I could do, this entire length is 6x minus 6. That part of it is 20. So I could do 6x minus 6 minus 20 and say that this part here is 6x minus 26 if I really wanted to. And then I could do 6x minus 26 over 12. That would work. But what's looking like it would be easier to me right now is that I see that the entire length is 6x minus 6. I see that this part here is the entire length, which is 15 plus 12, which is going to be 27. So I have the 20 over the 15. Those are across from each other. And then I have this 6x minus 6 across from that 27. So it equals 6x minus 6 over 27. And from here we can cross multiply. So 27 times 20 is going to be 540. From here, let's see, I do the 15 times that 6x minus 6, distribute out that 15. So I have 540 equals 90x minus 90. Add 90 to both sides. 630 equals 90x. Divide both sides by 90. And I get x is going to equal 7 here. So with these ones, with numbers 2 through 7, just pay attention to what's across from what, whether it's the entire side length or just a part of it. That's the biggest key here. All right. Number 8. So with this one, the cities of Georgetown and Franklin are 9.7 inches apart on a map that has a scale, so that's a scale factor, of 1.1 inches to 16.5 miles. I see that word 2. We know that that word 2 is going to become that colon when we set up a ratio, or that fraction bar. So what I can do here, I'm comparing inches to miles. So remember, we have to keep our consistency with word problems like this. So I can say inches over miles. So it's 1.1 inches to 16.5 miles. So inches to miles, 1.1 to 16.5. And then I have this 9.7, that's the number of inches. So inches are going in the top here, so I'm putting 9.7 in the top. And then I want to know how far apart are they in real life. So that's going to be a number of miles, so I'm putting that in the bottom. That'll be my x. From here, we just cross multiply and solve. So let's see, 1.1 times x is just going to be 1.1x equals, and then in my calculator right now I'm doing 16.5 times 9.7, which is 160.05, 160.05. Divide both sides by 1.1, and I'm getting that x is going to equal 145.5, and this is the number of miles, so I'll say 145.5 miles. There we go. So that's our answer there. Number 9. A 46-foot flagpole casts a shadow that is 253 feet long, as we can see in this diagram here. So here's my 46-foot flagpole. There's my 253-foot shadow. That's a question mark. So that's our x. And we have this woman who is 5 feet 6 inches tall. So remember, there are 12 inches in a foot. So this is not going to be 5.6 because there are 12 inches in a foot. So 6 is half of 12. So it's 5.5 feet or 5.5 feet. So, 6 over 12 equals just 0.5. So it's 5.5. So her height is going to be 5.5 here. not 5.6, 5.5. There's a couple different ways we could set this up. Let's see, what I'll do is the height of the woman over the length of her shadow. So 5.5 over x equals the height of the flagpole over its shadow. So 46 over 253. So again, just keeping it consistent, I'm doing height over shadow, height over shadow. From here, I'm going to cross multiply and solve. So 5.5 times 253 is going to give me 1,391.5. 1,391.5 equals 46x. Divide both sides by 46 there. So that's going to give us x is going to be 30.25 feet. So she's going to be casting a shadow that's 30.25 feet long. And that's how to do number 9. All right. Yeah, next one. All right, number 10. So this is what we did yesterday or Monday. So we want to solve for x and find the scale factor. I'm going to find the scale factor first. So remember, the scale factor is the distance from the center to P prime divided by the distance from the center to the original. So the center is right here. That's our center of dilation. And we can see that this tall guy, he's P prime. So the distance from C to P prime, 75 plus 50, is going to be 125. So K is our scale factor, and that's going to equal prime over original. So the distance to the prime is 125. The distance to the original, to P, is 75. So the distance from C to P is just 75. The distance from C to P prime is 125. So it's 125 over 75. And now I'm going to simplify this fraction if I can. I see these are both divisible by 5, and more specifically, they're actually both going to be divisible by 25. So I can divide both of them by 25, and this reduces down to 5/3. So K equals 5/3. From here, I want to solve for x. So I have that scale factor. I have that 5 over 3. And now I have the heights. The height of the prime is x. The height of the original is 45. So if the height of the prime is x, again, I want to keep it consistent, do that prime over original. So the height of the prime is x. The height of the original is 45. So I'm doing 5 over 3 equals x over 45. We will cross multiply. Let's see, 5 times 45 is 225. Is going to equal 3x. Divide by 3. And we're going to get x equals 75. So that's our answers to number 10 there. So find the scale factor and then use that to solve for x. Just remember prime over original. Keep telling yourself that. Keep telling yourself that prime over original and you'll be fine. Okay, number 11. Determine the coordinates of the image of triangle XYZ under dilation with a scale factor of k equals 3/4. So 3/4, you might not know what that is. So I'm typing that in the calculator right now, 3 divided by 4, and I'm getting 0.75. So, a dilation means I'm going to be multiplying all the coordinates by the same number, and that number is going to be 0.75. So first thing I need to do is find where the coordinates are of x, y, and z. So x, let's see, x is at -8, -2. Y is at, that is 0, and then -6. And then z looks like it is at -12, -12. And what I need to do now to find x prime, y prime, and z prime is multiply everything by 0.75. So in a calculator, I'm just going to do all these numbers times 0.75. So 0.8 times, or not 0.8, negative 8 times 0.75 is negative 6. Negative 2 times 0.75 is going to be negative 1.5. So I know that that's my x prime. I can say negative 6, negative 1.5. For y prime, well, 0 times anything is just going to be 0. So the x value is going to be 0 there. Negative 6 times 0.75. So negative 6 times 0.75 is negative 4.5. So y prime is at 0 and negative 4.5. And then z prime, let's see. So z prime, I'm going to take negative 12 times 0.75, and I'm getting negative 9. So both the x and the y coordinates should be negative 9. So negative 9 for z prime. Negative 9, negative 9. And part of the question here says, then graph x prime, y prime, z prime. So I have to graph these points now. So let's see, negative 6, negative 1.5. So negative 6, negative 1.5 is going to be right there. There's my x prime. 0, negative 4.5. So there's negative 5. So it should be half line above it. So that's y prime. Let me make that a better y. That's an ugly y. Okay, y prime. And then z prime should be at negative 9, negative 9. So that will be right here. So this is z prime. And then I'm going to connect these points. And it should look like a triangle that is the same shape, but smaller than the original triangle. So it does. About 0.75 times the size of that original triangle. So that is how to do number 11. Just make sure you graph it and get all your coordinates. All right, then I have number 12. So number 12, circle the type of dilation and find the scale factor. So again, as we did in number 10, the scale factor is going to be prime over original. So I see that this smaller one is p prime. I see that this bigger one is p. So that number on the prime is 10. The number on the original is 18. 10 over 18, I can divide both those by 2. So that's just going to be 5 over 9. That can be simplified any further. So k equals 5/9. We need to identify whether it's a reduction or an enlargement. And remember, it's going from the original down to the prime, or up to the prime. So I have this original is p, and then after the transformation, it's going to be a p prime, meaning it's going from there to there. So it is shrinking, and it is a reduction. And that's our answer. So number 12, it's a reduction, and the scale factor is 5/9. All right, then I have these ones. So these ones, yeah, so these ones, it's just the stuff we did earlier in the unit with like identifying why they're similar. And we know that the possible reasons they could be similar, we have SSS, AA, or SAS, or just not similar. So looking at this diagram, I can see that these two angles are vertical angles, so they're going to be congruent. And I see just two pairs of sides on each triangle. I don't see the third side, like this LM and this CD. I don't see any numbers for those. So I know if these are similar, it's going to be because of SAS. So I know it's not SSS. I know it's not AA. I don't have three sides. I don't have three angles. I have two sides and one angle. So now I just need to determine if they're similar or not. So I'm going to match up the sides. So we have, let's see, KL and KC. So KL is this 88, KC is this 48. So I will do 88 over 48 equals, all right, so then I have the 88 is on the same triangle as the 77. And the 48 is on the same triangle as the 42. And then we're just going to reduce these down. I did tell some of you that what you could do if you don't know the GCF of these certain numbers, how to reduce it down, what you can do is just type it in the calculator. I can do 88 divided by 48 and then 77 divided by 42 and just make sure it's the same decimal. And if it's the same decimal, then yes, they're similar triangles. But with this one, let's see, 88 and 48, I can divide both those by 8. So I take 8 out, and that's going to give me 11 over 6. And then 77 and 42, I can divide both those by 7. 77 divided by 7 is 11. 42 divided by 7 is 6. So it's 11 over 6 equals 11 over 6. So yes, these are similar because of AA, or SAS, my bad. So we had 2 sides and 1 angle. So they were similar because of SAS. All right, number 14. So this one, I have 2 angles. I don't see any numbers at all. So I have 2 angles that are congruent. E is congruent to U, D is congruent to V. So this is AA. Number 15. So PQR is similar to FGH. I see 3 sides. I don't see any angles. So I know it's not going to be AA. I know it's not going to be SAS. It's either going to be SSS or just not similar. So looking at the statements, let's see. I see PQ and FG would match up. So PQ is the 48. FG is the 40. Then what do I have? I have QR and GH. So QR is the 60. GH is the 51. And then I have the first and third letter, the PR and the FH. So PR is 84. FH is 71. And from here, I just want to reduce these fractions and make sure they all come out at the same thing. If they do, it's SSS. If they don't, it's not similar. So 48 and 40, like I said, you can just type this in a calculator if you want to. That works perfectly fine. And see if they all come out to the same decimal. Let's see, 48 and 40, I can pull out 8 from both of those. So 48 divided by 8 is going to give me 6. 40 divided by 8 is going to give me 5. Then I have 60 over 51. The GCF there is going to be 3. I divide both of them by 3. So 60 divided by 3 is 20. 51 divided by 3 is 17. And then 84 and 71, there actually is no GCF there. So 71 is a prime number, so it can't be divided any further. So this is as far down as these fractions go. And if I were to type these in a calculator, let's see, 6 divided by 5 is 1.2. So this first one is like 1.2. Then I have 20 divided by 17. This second one is going to be like 1.18. And then 84 divided by 71. That one's also approximately 1.18, but it's like a different 1.18. So we can see that these are not the same. They're just not the same. These are not similar. So it's A for number 15. And finally, I have number 16. So number 16, I have NM is going to match up with ST. And oh, by the way, yeah, so looking at the diagrams, I don't see any angles, so I know it's not going to be angle-angle. I know it's not going to be side-angle-side. It's either going to be not similar or SSS, so either A or D here. So NM matches up with ST. So NM is this 24. ST is the 8. Let's see. Next we have ML matches up with TU. So ML is that 30. TU is the is the 10. So TU is the 10. And then we're going to have the first and third letter, so NL and SU. So NL is the 42. And SU is the 14. And now we just want to reduce all of these. So 24 over 8, you can divide both those by 8, and that just reduces down to 3 over 1. 30 over 10, divide them both by 10, and you get 3 over 1. 42 over 14, divide them both by 14, and we get 3 over 1. So all 3 of these are the same. So these are similar, and it is SSS. I have 3 sides that are proportional to one another. So our answers for 13 through 16 were D, D, A, D. So SAS, AA, not similar, SSS. All right, we got 3 more problems. No, 4 more problems, my bad. So number 17 here. So given that they're similar, we want to solve for x. We're given this statement, so FGH is going to be similar to CBA. So let's see, FG and CB. FG is this 13x, CB is the 70. So if I want to, it does help for some people to just color code it and color in the sides, like I was doing in the notes that one day. So we can see that these two sides are going to be congruent, or not congruent, similar. And then the other sides, so the 40 and the 104 are going to match up. But when we're doing this, just make sure that we have the same triangles like in the top or the bottom. So like if I put the 13x in the top, I have to put the 104 in the top as well. So yeah, so the 13x is going to match up with the 70. So I can say 13x over 70 equals, and again, since the 13x came from the, or is going in the top, the 104 has to go in the top as well. And the 40 would go in the bottom. And the 70 and the 40 are from the same triangle, so they would go in the bottom together. From here, we're going to cross multiply. So 13 times 40, that gives me 520x. And then 70 times 104, so 70 times 104 is 7,280. I'm going to divide both sides by 520. And I'm getting that x equals 14. And that's our answer. All right, then I have number 18 here. So I have this 8x minus 10 is that part right there. I have the 84 and the 66 are across from each other. And then I have this 121 is the entire side length. So some things I could do, I could find the entire side length over here of JL by doing the 8x minus 10 plus 84 to get 8x plus 74. Or I could just do the 121 minus the 66 to get this part here, which would be across from that 8x minus 10. So 121 minus 66 is going to be 55. So this right here is 55. And now I can see I have this 8x minus 10 across from that 55, and I have this 84 across from that 66, so I can set it up just like that. So I have that 8x minus 10 on the 55 equals the 84 over the 66. From here, we will cross multiply and solve. So I have, let's see, 66 times 8x minus 10 equals 84 times 55 is 4,620. Distribute this 66 here. So 66 times 8 is 528x, and then minus 660 equals 4620. So I'm going to add 660 to both sides. So 4620 plus 660 is going to be 5280. So I have 528x equals 5,280. Divide both sides by 528. And we're going to get x equals 10. And there we go. All right, so that's how to do 17 and 18 there. Then I have this number 19. So triangle NOP has side lengths 12, 14, and 15. If QRS is similar to NOP, which is the volume to be the side length of QRS. So 12, 14, and 15, these are three side lengths. What I want to do is I just want to see which of these ratios is proportional, and it's only going to be one. So what I could do is I have the 12 as the first side, the 1 is the first side, so I could say 12 over 1, and so the 14 is the second side, the 3 is the second side, 14 over 3, and the 15 is the third side, the 4 is the third side, so I could say 15 over 4. I could reduce these down, and none of these are actually going to reduce, so this one is just not going to be it. But I could also, what I recommend doing with this one is I would just type it in the calculator. So do 12 divided by 1, 14 divided by 3, 15 divided by 4, and see if they're all the same number. If they're all the same number, then it's that one. It's proportional. All right, so that's the first one. So we know it's not going to be A. So it's not A. So here I can do 12 over 4 equals 14 over 5 equals 15 over 5. Okay, so again, if I type this in the calculator, 12 over 4 is 3, 15 over 5 is 3, but 14 over 5 is 2.8. So 3, 3, and 2.8. So it's not this one. For C, let's see. I can do 12 over 22, 14 over 24, and 15 over 25. So let's see, 12 over 22 is 0.545. 14 divided by 24 is 0.583. And 15 divided by 25 is 0.6. So none of these are the same decimal. And if I were to reduce these, let's see, I can divide the first two. I can divide this one by 2. I can divide this one by 2. This one I would divide by 5, and they would just not reduce to the same thing. So it's not that. All right, then I have this D. So let's see. For D here, I got 12 over 72 equals 14 over 84 equals 15 over 90. So 12 divided by 72, doing that on my calculator, is 1.6 repeating. 14 divided by 84, doing that on my calculator, I'm also getting 1.6 repeating, so this one's looking good so far. And then 15 divided by 90, it's also 1.6 repeating. So all three of those are the same, so our answer here should be D. And then if I want to check E as well, I'll do that. So I have 12 over 16 equals 14 over 42 equals 15 over 45. So 12 divided by 16 is going to be 0.75. 14 divided by 42, that's 0.3 repeating. And then 15 divided by 45 is also 0.3 repeating. So we can see that these two are equal, but that one is not. So these are just not similar at all. So it's not E. So it's D with our answer there. And then I have number 20. So this one is select all that apply. Which of the following proportions could be used to solve for x in the following diagram? All right, first thing I want to do with this problem is I want to figure out this length here and this length here. So I know the entire length here is 36, and that part of it is 21. So I do 36 minus 21. So 36 minus 21, and I get that this right here is 15. Because I know that if I were to add the 15 and the 21 together, it would give me that entire length of 36. Then I have this part here. So I know the entire length is x. I know this part is 10. So I can do x minus that 10, and I can just leave it like that. So x minus 10. So this part here will be x minus 10. All right, what I'm going to do now, and what I recommend you guys do, is highlight it, color code it somehow. I have colored pencils in my room that you guys are more than welcome to use. So let's see, I have this x and that 36 are across from each other. They're both the entire side length. Then I have this 10 and the 15 are across from each other. And then I have the x minus 10 and the 21 are across from each other. Now I'm going to go over to my options and highlight those. So the x minus 10, I highlighted that yellow, same with the 21. So everywhere I see a 21 or an x minus 10, I'm going to highlight it in yellow. So there's my 21s, those are my x minus 10s. Yeah, that's it. All right, so the blue, let's see, that was the 10s and the 15s were highlighted in blue. So everywhere I see a 10 or a 15, just by itself, I'm going to highlight those in blue. Yeah, that looks right. And then I have the x and the 36 were highlighted in red. So everywhere I see an x and a 36, I'm going to highlight those in red. All right, so now that I've highlighted it, Looking at the options, I see A. Well, A has blue over blue, red over red. That's fine. I'm allowed to have that. Blue over blue, red over red. B, yellow over blue, yellow over blue. That works just fine. I can do that. C, red over yellow, red over yellow. I'm allowed to do that. That works. D, red over red, blue over yellow. That doesn't work. I would have to have red over red, blue over blue, or red over red, yellow over yellow, or I don't know, blue over yellow, blue over yellow. Either way, it has to match up somehow. This does not. So it's not D. And then I have E with this x plus 10 and this 57. That would come from like adding these numbers and these numbers, or wait, these numbers together, which, is just, there's no reason I would do that. That's just not going to make sense. So that x plus 10 and that 57 are not even part of this. So E is definitely not it. So select all that apply. It was A, B, and C. And those are our answers here. Like I said, I highly recommend using colors, color coding things, especially with these similar triangles, so you can see what's going to match up with what. It was helpful for number 1 here. It can be helpful on number 20. It can be helpful on a lot of them. But yeah, that's how to do everything here.